Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is nomenclature of organic compounds using IUPAC rules. If you are in class 11 and just starting with organic chemistry, you might find nomenclature a little challenging at first, but by the end of this session, you'll have a clear understanding of how to name organic compounds systematically using IUPAC rules. Understanding nomenclature is not just important for scoring well in exams like NEET and JEE, but also forms the foundation for advanced organic chemistry concepts that you'll encounter in class 12 and beyond. To start, nomenclature is the system used to name organic compounds. Since organic chemistry involves millions of different compounds, a standardized system was essential to avoid confusion. This is where the International Union of Pure and Applied Chemistry, IUPAC, comes in. IUPAC created a systematic method that assigns unique names to compounds, ensuring that chemists all over the world can refer to the same molecule without ambiguity. The name of any organic compound consists of three main components: a prefix, a word root, and a suffix. The prefix indicates the substituents or functional groups attached to the main carbon chain, the word root tells us the number of carbon atoms in the longest continuous chain, and the suffix highlights the functional group or the type of bond present in the compound. When naming an organic compound, the first step is to identify the longest continuous chain of carbon atoms. This chain becomes the parent chain, and the name is derived based on the number of carbon atoms it contains. If there are multiple chains of equal length, the chain that contains the most substituents or functional groups is selected. Once the parent chain is determined, the carbon atoms are numbered in a way that gives the lowest possible number to the substituents or the functional groups. This step is crucial because it minimizes ambiguity and ensures consistency in naming. After numbering the carbon chain, we move on to identifying the substituents. Substituents are groups of atoms attached to the parent chain that replace hydrogen atoms. Common alkyl substituents include methyl, ethyl, propyl, and butyl groups. If more than one identical substituent is attached to the parent chain, we use prefixes such as di, tri, and tetra to indicate the number of times the group appears. For example, if there are two methyl groups attached to the same chain, the prefix di is used and the name becomes dimethyl. These substituents are listed in alphabetical order when writing the final name of the compound. The next step is to identify the functional groups present in the molecule. Functional groups are specific groups of atoms that determine the chemical behavior of a compound. Different functional groups have different suffixes that are added to the base name of the parent chain. For example, if the compound is an alkane, the suffix ane is added. If it is an alkene, the suffix becomes ane, and for alkynes, the suffix is yane. In the case of alcohols, the suffix changes to ol, and for carboxylic acids, the suffix is oic acid. When a compound contains multiple functional groups, there is a specific order of priority that determines which group will take the suffix, while the others are treated as prefixes. When dealing with cyclic compounds, the prefix cyclo is added before the name of the parent chain. The carbon atoms in the ring are numbered in such a way that the substituents get the lowest possible numbers. For example, if a methyl group is attached to a cyclopentane ring, the name becomes methylcyclopentane. If there are multiple substituents on the ring, they are listed alphabetically, and the numbering is done to give the lowest set of locants. Aromatic compounds like benzene follow slightly different nomenclature rules. A benzene ring with a single substituent is named as a substituted benzene. For example, a benzene ring with a methyl group attached is called toluene. When multiple substituents are present on a benzene ring, their positions are indicated by numbers, with the goal of giving the lowest possible set of numbers. Common names like ortho, meta, and para are also used for disubstituted benzene compounds to indicate the relative positions of the groups. Sometimes, organic compounds contain branched or complex substituents that need to be named separately. In such cases, the substituents themselves are treated as a separate entity and enclosed in parentheses. For example, if a complex alkyl group is attached to the parent chain, its name is derived based on the number of carbon atoms and the position of branching. The entire name of the substituent is placed in parentheses to distinguish it from the parent chain. Another important concept in nomenclature is the consideration of stereochemistry, especially in compounds with double bonds or chiral centers. Geometric isomers of alkenes are denoted by the prefixes CIS and trans, or by the more precise E and Z notation. CIS isomers have the same groups on the same side of the double bond, while trans isomers have them on opposite sides. In more complex cases, the EZ system is used based on the priority of the groups attached to the double-bonded carbon atoms. When dealing with chiral centers, the RS system is used to describe the absolute configuration of the molecule. These designations help in distinguishing between enantiomers, which are non-superimposable mirror images of each other. Although stereochemistry might seem like an advanced topic, it is an integral part of understanding the three-dimensional arrangement of atoms in organic molecules. As you can see, the IUPAC system provides a comprehensive and logical framework for naming organic compounds. While the rules may seem extensive initially, practice makes the process much easier. By regularly working through examples and naming different types of organic molecules, you'll develop the confidence to apply these rules effortlessly in your exams. Thank you. That's it for today's session on nomenclature of organic compounds using IUPAC rules. We've covered everything you need to know to start naming organic molecules correctly. Stay tuned to AskPrep for more in-depth explanations of essential chemistry concepts. If you found this video helpful, don't forget to like, share, and subscribe to our channel so you never miss any of our upcoming content. Thanks for watching, and see you in the next session.